Hi, everybody. Today we're going to talk about inequalities. By now, you should have already learned how to simplify expressions and also how to solve both one-step and two-step equations. If you're not comfortable yet with any of those, I would really encourage you to go back and watch or rewatch those videos because you're going to need those concepts as we move forward with inequalities. So inequalities have these signs right here. This is, less than. The next one is greater than, less than or equal, or greater than or equal. They will not have just a straight equal sign. You're going to still solve them like you do equations by using inverse operations. And it's going to be really important to keep everything in line vertically, up and down. You want to be sure to write the complete solution. So where with an equation, when you solve it, if you get x equals 5, it's no big deal if you just write 5. But with an inequality, you would have to write the complete x is less than 5 or whatever it is. Your solution's not just one number like it is with an equation. We'll talk more about that in just a little bit when we get into graphing. But for right now, let's get some practice solving these. So in the first example here, I'm still going to split this like I would through an equal sign. I'm just going to go through the inequality sign. And if you want to box it, you can. Now, this particular one is not a two-step equation, meaning there's not a number attached to the x. So I'm not going to need to remember what comes first and what comes second because there's only one number to get rid of. All of my focus goes to the left side because in this inequality, that's where my variable is. I see addition, and I know that the opposite or inverse of adding is subtracting. So I'm going to subtract 4 on the left, and I'm also going to subtract 4 on the right. It's a teeter-totter that we want to keep balanced. Now go straight down your columns. So on the left, I still have an x. Plus 4 minus 4, they cancel out. That's the whole reason why we did that. Bring my inequality symbol down. And then on the right, a -7 and a -4. If I owe 7 and now I owe 4 more, altogether I owe 11. So my solution is that whole three-part thing right there. X is less than -11. It means anything that's smaller than -11 would work when you plug it into this sentence, to this inequality. Let's do another one. I'm going to draw a line through my inequality sign. This time my variable's on the right, so I'm going to put all my attention over there. There's nothing attached right beside or right under the x, so all I have to do is get rid of that -3. The opposite of subtracting is adding, so I'm going to add 3 on the right. To keep it balanced, I'm going to add 3 on the left. Now straight down my columns. 2 plus 3 is 5. Bring down my inequality sign. Bring down my x. -3 plus 3, they cancel. So my solution is this whole thing. 5 is less than or equal to x. For this one, that means x is actually bigger, right? Think of your sign. You might have heard when you were little to think of it as like an alligator. And the alligator always eats the bigger part because it's hungry. I never did an alligator. I always did Pac-Man because I'm not really an artist, but any old dum-dum can draw a Pac-Man, right? Aren't I so good? So Pac-Man always eats the bigger part. So on the first one we did, x is smaller because it's not eating the x. On this next one that we did here, x is bigger because Pac-Man's eating the x. With the equal to sign, it means 5 would work, or anything bigger, greater than 5 would work. We're going to focus more on exactly what the less than and greater than means in just a bit when we start graphing. For now, let's continue to practice solving. On this next one, I'm going to split through my sign. Now, I've got a 5 right beside the x. When they're right beside, it means times. The inverse of multiplying is dividing. So I'm going to divide both sides by 5. I want to keep it balanced, so do it to both sides. On the left, the 5 cancels, and I just have an x. Bring down my inequality symbol just as you see it. -40 divided by 5 is a -8. 8. My solution, I want to write that whole thing. X is greater than or equal to negative 8. With the equal sign, it means negative 8 works if I plug it in, and then it's eating the X, so also anything bigger than negative 8 works. Okay, on the next one, I'm going to split it through my inequality sign again. All of my focus is going to go on the right because that's where my variable is. I see a fraction bar. We know that a fraction bar is another way of telling us to divide, and the opposite of dividing is multiplying. If I multiply on the right to cancel that, I need to multiply on the left to keep it balanced. Now straight down my columns. 3 times 8 is 24. Bring down my greater than. Divided by times they cancel. If I separate the groups, but then I bring the groups back together, it's like I never did anything at all. So I just have an X. So my solution, I need to write that whole thing. 24 is greater than X. It's not eating the X, so X is smaller. That means anything in the world that's smaller than 24, even if it's 23.99, it would work if I plugged it into that inequality. A lot of what we're going to focus on is going to be two-step inequalities. So just like we did with two-step equations, I'm going to split it. And now I do have two numbers on the same side as the variable. So what I encouraged you to do with the two-step equations was to box that X term, the variable. That's my reminder that that 9 is best friends with the X, and they are going to hang on to each other until the very, very end. So what we need to do is get rid of the plus 4. I want to know what I had before I added the 4, so I'm going to subtract it out of there. Do it on both sides to keep it balanced. And now bring everything straight down. On the left, I have 9x plus 4 minus 4 by, bring down my less than or equal to sign. And now negative 32 and negative 4 altogether would be a negative 36. Back to my variable. It's not alone yet. It still has that 9. I need to know what I had before I multiplied by 9. So I'm going to do the opposite. I'm going to divide both sides by 9. Now on the left, those cancel and I just have my x. Bring down my less than or equals. Negative 36 divided by positive 9 is a negative 4. For my solution, I need to write that whole thing. X is less than or equal to negative 4. The equal to sign means negative 4 actually will work if I plug it in. X is smaller, so anything smaller than negative 4 would also work. Let's do one more of those. On this next one here, I'm going to split it. I'm going to box it. All of my attention is on the right side. The 6 is within the box, so I need to get rid of that minus 2. The opposite of subtracting 2 is adding 2. Keep it balanced. If you do that to the right, then do that to the left. And now go straight down. That gives me 3 is greater than x over 6 minus 2 plus 2. Bye-bye. Now back to my variable. Fraction means divide. The opposite of dividing is multiplying. So to cancel out that divide by 6, I'm going to multiply by 6. Keep it balanced, so do it to the other side as well. 6 times 3 is 18. Bring down my greater than. Those cancel and just give me x. I need to write the whole 3-part solution. 18 is greater than x. X is smaller because Pac-Man's not eating it. So that means anything that's smaller than 18 would work. Now, there is one exception to all this that we've been talking about. The only thing in solving these that is ever different than a normal equation, if you have to multiply or divide by a negative in order to get your variable by itself. It doesn't matter if your answer is positive or negative. But if that final step to get your variable alone is to multiply or divide by a negative, then you're going to take that inequality sign and flip it around to make it face the other way. Okay, here's what I mean. This first one that I have written here. Now, negative x over 2, I could have that negative sign on the top, on the bottom, or just out to the side. So what I usually do on these is I just kind of change where it is. You can either literally do this or you can just remember. But I'm going to put that negative sign with the number because that's a whole lot less confusing than having it with a variable or just hanging out on its own there. So when I focus all my attention there on my variable, I've got x divided by -2. To cancel out the divide, I'm going to multiply. I'm multiplying by a -2. Negatives just kind of mess things up, don't they? They make everything go a little bit funky. So I still have an x. Over here, I would get a -6, but check it out. Because I multiplied by a negative, when I bring that inequality sign down, I'm going to make it open on the other side. So my final answer is x is greater than or equal to -6. It has nothing to do with my answer being negative. It's because this step right here, when I had to multiply, I had to multiply by a negative. Let's do another one. Now, this one's a two-step equation. I'm going to split it, or here I said equation, inequality. We've been working on equations in class, so it's just on my brain. I'm going to split it. I'm going to box it. I've got to get rid of that -6 because that's with the variable, but not in the box. The opposite of subtracting 6 is adding 6. And if I do that to the right, I need to do that to the left. I'm going to go straight down my columns. This gives me a -24. Now look, I was adding. This had nothing to do with multiplying or dividing, let alone by a negative. So this sign right now is still facing the same way. Bring down my -3x. This cancels. Back to my variable. I have a -3 right beside it. It's not about canceling out the number, it's about canceling out the operation. When they're right beside it means times. So to undo that, I need to divide by a -3. And if I do that on one side, I've got to do that on the other side to keep it balanced. -24 divided by -3 is a +8. On the right side, they cancel and just give me x. But look, because I had to divide by a negative number, and anytime you multiply or divide by a negative, you flip the sign. So I'm going to bring not the greater than sign down. I'm going to bring a less than sign down. So my final answer is 8 is less than x. Now, we've been talking throughout this here about what your solution really means. And I've been talking about how what you plug in, it's got to fit the description of your inequality. So if it says, like on this first one here, x is less than 3, it means anything in the world that's smaller than 3 would work in that particular inequality. It could be a 2, it could be a 1, it could be a -99. As long as it's smaller than 3, it works. So you illustrate that on a number line. Now, your number line, if you're drawing your own, doesn't have to be huge. It doesn't have to have 50 bajillion numbers on it. I make mine pretty small and simple. I put whatever my solution is in the middle, and then I put one number on each side. So this would be a 2, and this would be a 4. Make sure that if you get a negative number, which you will sometimes, negatives count backwards. So make sure when you fill in those 3 intervals that they're really counting as they truly would on a number line. Okay, next thing you do, some people will put it right on the number. Some will put it just a little bit above. What I have noticed the past couple of years on our state test, which here in Indiana, it used to be called iStep, now it's iLearn, you're usually dragging the solution the way the point will look in the graph. And it's easier to see if you put it just a little bit above. I think a lot of times that's what it looks like on that test. So I'm going to do mine just a little bit above. Okay. So I'm going to start always with an open circle. Now, here's how I remember it. If your inequality sign has something extra, like the line underneath, you do something extra and you color it in. Mine doesn't have that. So I'm going to leave that open. What that means is that 3 is like a starting point, but it's not actually part of my answer. I can get really, really close to 3, but I can't actually hit the 3. Now, it's not eating x. X is smaller. So I'm going to shade to the left because that's where my smaller numbers live. And like I said, you can do this right on your number line if you want. That would look like this. Or you can put it just a little bit above. Check a number that you passed through and make sure it works. So I passed through a 2. If I put that in, it would say 2 is less than 3. That's true, so I know I shaded the right way. Now, the one below this looks very similar. It's got that same less than sign, but the X is on the other side. You will hear some people tell you that whatever way the arrow points, that's the way you shade. Like, look, this symbol here, this less than, looks like an arrow pointing left, so we shaded left. I don't like that though. It gets confusing because that only works when your variable is on the left of your inequality. So I would really, really encourage you not to go by that little rule, that little trick, because as you'll see on this next one, when the variable's on the right, it's totally backwards. So I wouldn't do that. I would always ask yourself, is the variable bigger or smaller? And you know that by whether or not Pac-Man's eating it. And then you shade right for bigger, you shade left for smaller. So I'm going to put my 3 intervals on here. I'm going to put my number in the middle, put whatever comes before it and after it. Start with an open circle. This one, again, I don't have the equal to line. Since I don't have that something extra, I'm not going to do something extra by coloring in my circle. I'm going to leave it open. But this time, Pac-Man is eating my X. That means X is bigger. So I'm going to shade to the right because that's where my bigger numbers always live. It doesn't matter if they're positives or negatives. Smaller numbers live left, bigger numbers live right. Now take something that you shaded past and see if it works. I shaded past a 4. If I plug that in, it would say 3 is less than 4. That is true. So I know I shaded the right way. Let's do a couple more and then we're going to solve and graph all together. Okay, so on this one, I always do 3 intervals, put mine in the middle. These are positives, so this would be 4, 5, 6. Start with an open circle. Now this one does have the extra equal to line. So I'm going to go that extra step and I'm going to color it in because what that means is that 5 isn't only like my boundary, it actually works in my solution. It's part of it. So I color it in to show that it's included. Pac-Man is eating X. That means X is bigger. So I'm going to shade right because that's where my bigger numbers live. Let's take a number that we shaded past and check. This would say, let's see, I shaded past a 6. 5 is less than or equal to 6. Well, yeah, it's less than 6, so that works. Let's do one more. Okay, interval, interval, interval. My number in the middle, whatever's on the left, whatever's on the right. Start with an open circle. I wanted, again, to make this one look very, very similar, but if you notice, I flip-flopped which side the X was on. So this one does have the equal to line. I am going to color it in. X is smaller. Pac-Man's not eating X. So I shade left because that's where my smaller numbers live. Plug in a number you went past. I went past the 4. 4 is less than or equal to 5. Well, yeah, 4 is less than 5, so that would be good. Okay, we're going to do a couple of these with all of those concepts that we just breezed through, putting them all together. I would encourage you, if anything wasn't quite making sense, back the video up to where you started feeling confused, listen one more time and see if any of that sinks in a little bit better, and then consider pausing the video and trying these. When you feel like you have an answer you're happy with, resume the video and we'll see if we match. Okay? All right, so here we go. I'm going to split it. I'm going to box it. I need to get rid of that plus 3. The opposite of adding 3 is subtracting 3. I'm going to do that to both sides to keep it balanced. Straight down my columns. X over 4. These cancel. Bring down my sign. 1 take away 3 is a minus 2. Back to my variable. The opposite of dividing by 4 is multiplying by 4. I do that on both sides to keep it balanced. On the left, it cancels and gives me X. On the right, negative 2 times 4 is a negative 8. Now, I did get a negative answer, but I multiplied by a normal positive 4. So I'm still going to use my greater than sign. I'm going to bring it straight down. You only flip it if you multiply or divide by a negative. Even though I got a negative, what I multiplied by was a positive. So my solution is this whole three-part answer. X is greater than -8. I'm going to put that on a number line now. I don't need anything big. 3 intervals will do you just fine. Put the answer in the middle. Now, negatives count backwards. So -7 would be over here and -9 would be over here. I'm going to start with an open circle. I do not have the extra equal to line under my inequality symbol, so I do not want to go the extra step of coloring it in. It means -8 is a boundary, but it's not actually part of the answer. Pac-Man is eating my X. That means X is bigger. So I'm going to shade to the right because that's where the bigger numbers live. There's my solution. There's the illustration of my solution. If you want to double check that you shaded the correct way, pick a number that you shaded past. So in this case, it would be -7 and see if that works. -7 is greater than -8. Well, yeah, it is because negatives count backwards, right? -7 is not quite as far in the hole as -8. So I know I'm good. Okay, let's see how you did on the next one. If you haven't done it yet, maybe pause and try it, okay? I'm going to split it. Oh no, why is it not writing? I've been doing so well. Okay, split it, box it. I need to get rid of the -10. So I'm going to add 10. And if I do that to the right, I'm going to do that to the left. Straight down my columns. 30 plus 10 is 40. I haven't done anything with multiplying or dividing yet, so I don't need to even worry about whether or not my sign flips yet. So just bring it down. I still have -2x, and then those go away. Now back to my variable. I have a -2 right beside it. When they're right beside it means times. The opposite of multiplying is dividing, so I'm going to divide both sides by -2. On the left, that gives me a -20. On the right, I just have my x. Now here's where we have to think about what we've done. The number that we divided by, doesn't matter what my answer is, the number that we divided by was a negative. So yes, we do have to reverse that sign. This is my answer, that whole thing. Now on my number line, 3 intervals is enough. I'm going to put -20 here. Negatives count backwards, so this would be -19 on the right and -21 on the left. Start with an open circle. My inequality sign does have the extra line, so I am going to do the extra step of coloring that in. It means -20 is actually part of the answer. Pac-Man is not eating the X. That means X is smaller, so I shade left because that's where smaller numbers always live. Let's make sure. Take the number you shaded past, -21. This would say -20 is greater than or equal to -21. Yes, it is bigger than -21 because negatives count backwards. So I've got my solution. I've got the illustration of my solution. Okay, I'm going to show you just 2 word problems. You should have already watched the video. If you're one of my students, you should have already watched the video and had in class about how to write equations for word problems. It's very much the same when you're doing inequalities. You just need to pay attention to the wording. With equations, usually you'll see just is for equals. Now we need to think about things like at most and at least and what those mean in the context of our problem. This says Matilda needs at least $112 to buy a new dress. She has already saved $40. She earns $9 an hour babysitting. Write and solve an inequality to find how many hours she will need to babysit to buy the dress. Interpret the solution. Okay, it says, find how many hours. So I'm going to use H, and I'm going to say H is for hours. Okay, let's go back up to the problem. I'm going to think about that at least here in a minute. What I'm comparing it to, the total amount that I'm really considering here is 112. So I'm going to put that on the right. On the left, I'm going to think about the rest of this information. She already has 40. Okay, so I'm going to write down 40. She's adding to that, right? She wants to make that a bigger amount. So plus $9 for every hour. I'm using H for hours. So that would be 9H. Now it says she needs at least 112. I already have this written up here for you, but if you can't remember, here's how you think about it. Ask yourself, if it says at least 112, would she be happy with exactly 112? Yes, she would, right? So that means I need the equal to sign. Would she be happy with less than 112? Nope. Would she be happy with more than 112? Yes. That's how I know it's greater than or equal. Okay, so I defined my variable. You should always have that on there. I wrote my inequality. Now I need to solve that. I don't want to mark up what I've written as part of my answer, so I'm going to do this over to the side. 40 plus 9H is greater than or equal to 112. I'm going to separate it and box it. To get rid of that 40, I'm going to subtract it. Do it to both sides to keep it balanced. Now I have 9H, positive 9H, is greater than or equal to 72. The opposite of multiplying is dividing. So I end up with H, I didn't divide by a negative, so keep the sign as it is greater than or equal to 8. So I'm going to write that down over here with the rest of the answer that it's been asking for. H is greater than or equal to 8. This particular problem did not say we had to graph it, but since we're still learning, I'm going to go ahead and show you. On my number line, I would put 8 in the middle, 7 in the 9. Hey, my very favorite math joke ever. If you didn't already think I was a dork, why is 6 afraid of 7? Because 7, 8, 9. But ching. Okay, yeah. I apologize. I apologize for my dad joke there. Let's see. I put my open circle on 8. This does have the extra line, so I am going to take the extra step and color it in. Pac-Man's eating H, so H is bigger. So I'm going to shade to the right. So there's my graph. Now it says interpret. Little hint in math. Anytime it tells you to interpret something, it just basically means put a label on it. Just say in words what it means. So if our solution was H is greater than or equal to 8, what I know is that she needs to babysit 8 or more hours. Okay, I have one last problem for you. Whoops. Okay, well, here's a fun thing. Somehow, I hit something that made my normal Jamboard go away, and now it's not letting me turn the page. Anybody know what I did? Because I've never seen this before. So this is super cool. What causes that? Oh, I somehow just made it bigger. Okay, minor technical difficulty. We're good now. Let's pretend like that never happened. If my joke already didn't make me look and sound dumb enough, then there's that. Okay, last problem, guys. You want to spend at most $12 on a carriage ride. The driver tells you there is an initial charge of $5 plus 50 cents per mile. Write and solve an inequality to find how many miles you can ride. Interpret the solution. First thing I always look for is what it's asking me to find. This says find out how many miles you can ride. So I'm going to define my variable. Again, that's something that we talked about in the video on two-step equation word problems. So I'm going to write down that M is for miles, or M represents miles. In Indiana, the wording that they usually use is define the variable. Other parts of the country will say write a let statement. So you would say let M represent miles. It's all the same thing. Okay, let's figure out how to write this. You want to spend at most $12. So that's kind of like the total in an equation. That's the amount that we're comparing everything to. So I'm going to put that on the right. On the left is where I put like the problem part of it. There's an initial or beginning charge of $5. So you have to pay $5 no matter what. And then you're paying more on top of that. So plus 50 cents per mile. That means 50 cents times every mile. So 0.50, I'm using M for miles, so 0.50 M. Now to figure out what symbol goes in here, it says at most. So the first thing I want to ask myself, if I spend exactly 12, is that going to be okay? It says at most, so that means I am willing to pay 12. Am I willing to spend more than 12? Nope. Am I willing to spend less than 12? Yes. So this one gets a less than or equal sign. To solve it, I'm going to go over here to the side so I don't mark up that part of my answer there. 5 plus 0.50 M is less than or equal to 12. I'm going to box it, I'm going to split it, I'm going to box it. Opposite of that, adding 5 is subtracting 5. So then I get 50 cents times every mile is less than or equal to 7. The opposite of multiplying by 50 cents is dividing by 50 cents. We can do this in our heads. It takes 2 of those 50 cents to make $1. We're trying to get to $7. So you would need 14 of those 50 cents to equal up to your $7. So M is less than or equal to 14. I'm going to write that up here. M is less than or equal to 14. Again, it didn't say I had to graph it, but I'm going to go ahead and show that just so we can get a little more practice. So my number goes in the middle. This would be a 15. This would be a 13. Start with an open circle. Mine does have that extra line, so I'm going to do that extra step of coloring it in. M is smaller because Pac-Man's not eating it, so I'm going to shade left because that's where the smaller numbers live. Interpret means say in words, put labels with it. So it says M is less than or equal to 14. We know M is for miles. So that means we can go 14 or less or fewer, however you want to say that, miles. Okay? That was a lot of information in this video because usually we'll split it up and we'll do 1 step and then 2 step and we'll do graphing along with all of it and then we'll do word problems. In my advanced class, we do it basically all together. In the regular math 7 classes, we'll kind of see how we're doing on time. This year has been a little nuts with COVID, and we're just generally pressed for time. But you can always rewatch sections of this video. You can always focus yourself on the parts that you need the most help with, and I will absolutely do the best I can in class to help you with the parts that you're not feeling super solid on. If you have questions, comment on the video or reach out to me. There's my contact information. And as always, I thank you so much for sticking through this if you watched all the way to the end. Thank you for your time and your patience with my technical difficulties and bad jokes as usual. Until next time, bye.